Hi, my name is Jeremy Wang. I'm the Executive Director for the University of Toronto Aerospace team, or UTAT, and I'll be talking about the drone, rocket, satellite, and outreach projects that the U of T Aerospace team is working on. Okay, so first of all, thank you very much for having me. Lori, great to be here. And as the introduction mentioned, I am with the U of T Aerospace team of UTAT. We are a student design team at the University of Toronto. But we like to think that we're really sort of a student-led aerospace institute of the university, and hopefully you'll see why very shortly. But first, I'll just give you a quick introduction of the team. So our motto is "Where ideas take flight," and the idea here is that in 2004, the team started as a group of 5 engineering science students who were designing gliders for a Canadian glider competition. For the most part, it was 5 students, 5 friends, who went to Stein's bar downtown every Friday, not while they were designing the gliders, but the team has grown significantly since then. And it was in about 2012 or 2013 that we started onboarding different projects, more people, and doing the things that we do now. So in this collage of sorts, you can see some of the projects that we've been working on over the past year. As the title of this presentation tells you, we work on drones, so fixed-wing drones. You can also see a multi-rotor kind of quadcopter, helicopter-type drone later on. We work on rocket propulsion and sounding rockets, which are high-altitude research rockets that conduct research within the Earth's atmosphere. We do a number of outreach activities as well, trying to get younger students as well as young professionals involved with aerospace in various capacities. And very recently, we also started building our own satellites, and we'll be launching our very first one in the next 2 years. So, at a very high level, we do have a vision and mission. We sort of run like our own sort of little startup or little company, really. That's the mindset that we have. Our vision is a community of ambitious young people who are leading aspects of the Canadian and global innovation infrastructure. And that's really high level, and maybe a little bit also quite grand, I think. But the idea here is that we're not just interested in design, we're not just interested in research, we're not just interested in university students, and we're not just interested in Canada. We're trying to do things that are bringing together people from all different kinds of industries, whether it's in aerospace or in fields related to aerospace, to do great things. The mission is to foster high-performance values and skills in the students that are on the team in an environment that is challenging and social. So, you're in university, you're taking 6 to 8 courses a semester, life is hard. And the idea here is that we want to make it harder, but also more fun. So we offer this environment where students can really delve into the creative side, besides learning the more essential theory that you learn in class. And at the same time, the things that we're working on are projects that we hope have real impact on the aerospace sector and society. Just an overview of what we do. So we are split into 5 different divisions. So we have, I'll just go through them one by one. So we have our UAV division, which does fixed-wing drones. We have an aerial robotics division, which does quadcopters and sort of hovering drones. We have a space systems division, which does pico satellites. So we're talking about satellites that are really the size of a loaf of bread, so extremely tiny. We have an outreach division, which works with, essentially does educational outreach projects around the city and across Canada. We have a rocketry division, which does rockets. And then we have an administration and advancement office, which handles all of the back-end sponsorships and partnerships and things that engineers take for granted for the most part. And at the same time, in terms of what skills students are developing, it's really a broad mix, right? It's not, as I said before, just the technical side. We're trying to foster people who are ambitious and have the necessary team skills, people skills to work in really kind of fast-paced, intense environments after they graduate or even while they're still part of the team. At the same time, we're also learning skills, and the team is constantly evolving. I myself, even though I've been here for 3 years and have been in this role for 1 year now, I'm constantly learning things. But you're also getting aspects of organizational administration, strategic planning, and to some extent the business side, especially if you're going out to companies and saying, you should give us $3,000 because X, Y, Z. And so for that reason, I find it very hard to tell people that UTAT is a design team. And it's something that I still think about. If you go to somebody and they they don't know anything about the U of T Aerospace team, what do you tell them? Do you tell them it's a design team? Do you tell them it's a student-led research group? I haven't come up with the best word yet, but regardless of what you choose to look at it as, it's not your average blank. Okay, I'll skip over this. We have a pretty broad administrative structure. I've been the executive director for this team for a year now. This is my second term. And we also have divisional leads, as well as people who are responsible for the admin and investment side. And some just miscellaneous statistics. So as I said before, we were originally founded in 2004 as the U of T Free Flight Glider Team. We've received more than 35 awards in the past 5 years from Unmanned Systems Canada, the Association for Unmanned Vehicle Systems International. IREC is a rocketry competition we attend. I hope you all know NASA and the UN. And as of right now, we have 85 plus active undergraduate and graduate students. So that really neat part about the team too is that we're not just undergrad students in engineering or even just in engineering science, which has the aerospace option. We have students from across all of U of T, including the Faculty of Arts and Science, who are helping us with the media side, helping us with the business side, or helping us with the science experiments that we conduct. So we have a number of physics and computer science students, for example, and we're even now taking students that are outside of U of T, working with universities like UTAT, Ontario College of Arts and Design, I believe, downtown, as well as Ryerson in various collaborations. Every year, we try to get the work that we do out in the public, or at least out in the academic professional community. And as Laura mentioned, I just returned from a conference in Mexico, which I got to attend because of the work that we had been doing in UTAT. So I was there to present some of the projects we've been working on in drones and rockets and space policy. And this is, so the very last part here, I don't think, this is not official, but I'm willing to bet a lot of things on it. We are Canada's largest and most comprehensive design team with 85 students, and these are active students. Our mailing list of people who say they're on the team but are not actually on the team is probably closer to 200. But the idea here is that we're trying to be as broadly focused as possible and going beyond just U of T. So, what are some typical reasons for why people join U of T Aerospace team? We have people on the team who have loved aerospace from the time that they were very young, 5 or 6 years old. I am not one of those people. I came into U of T engineering originally wanting to do biomedical engineering. I thought aerospace was useless. I didn't want to go to Mars and do things like that. And it was almost by accident I ended up joining this team. And it was at the Engineering Clubs Fair, which is an annual event that U of T hosts for all the incoming first years. And came across this team. I said, I like chemistry, maybe I'll join the rocketry division. I did, and that completely derailed everything I thought university was going to be and what I was planning originally to do. And now I smell of aerospace, people complain about it, people like it. But in the end, I'm very much an aerospace kind of person. And similarly, other students who join the team are not necessarily in aerospace engineering. Right? We have students from mechanical and industrial engineering who are learning about mechanical design, learning about practical fabrication skills with composites or metal machining. We have students from electrical and computer engineering who are learning about programming different kinds of controllers and stability in the context of aircraft designs. So it's really quite broad. So with that said, what we like to think is that being part of this team is not just a membership. And it's not just an affiliation or an extra line on your resume. The people who are part of the team are really part of the cause. And I say that in the sense that the organizational culture of this team is one that is so intense that requires so much dedication from students, and one where students are exhausted but they enjoy what they do on a daily basis, that you're really sort of breathing UTAT constantly. Okay, and with that said, there are 3 different reasons why people join, as I said before. Does anyone want to take a guess as to what these logos are? Anyone?
Money.
No, actually. Well, money in particular context. So these are not sponsors. These are companies that our students have either founded or gone to work at while they're part of the team, or shortly after they graduated. So you can see SpaceX is there, which we're very happy about. We have a number of sort of special partnerships with specific organizations where we'll provide our own internship placements for students to go work there. Bombardier is there, MDA, Honeywell, DLR is the German Space Agency, Kepler Communications is a startup that was founded by the past presidents of the team, and the Sky Guys is the startup that I founded or co-founded, and I'm currently working on right now. So one of the really practical things that students come to the team for is simply, I need experience, I need a job, I need to do something interesting and relevant to aerospace. The next reason why people come to the team is to be the aspiring Ironman. That's the kind of person that really wants to create something tangible, something tactile. On the far left, we have one of our fixed-wing drones that we've worked on in the past. That was entirely made by students. Everything we do on this team is done by students. The only things we don't do in-house is we purchase electronics from the outside, but anything mechanical is machined or handmade by students. So the entire airframe for that drone was made by students using molds and using carbon fiber. In the middle, we have a CNC mill that's machining one of the caps of a pressure vessel inside the rocket. And on the far right, we have another piece that was also machined by students. This is a bait connector as part of that same rocket. So besides the people who are being very practical and interested in getting a job, and besides the people who want to make stuff, there's also the very sort of people-minded, people-oriented members of the team who are there because they want to bring aerospace to other people, want to bring engineering and the kind of the ambitious culture and mindset to other people. So we have an outreach division on our team, as I mentioned before, and shortly after this I'll also be going individually into the different divisions and talk a little bit more detail about what we do. But within the team, when we get new members, there's very much a strong focus on mentorship relationships. So as soon as somebody joins the team, they get paired with somebody who's been there for at least a year. And through that, you pick out all the things that you need to know, whether it's skills or knowledge or kind of absorbing the culture. In addition to that, we also have people who will go out into schools in the Toronto area, or go out to other kinds of public events. Some of you may know Science Rendezvous, which is an annual sort of science street festival that's held downtown Toronto, where all the different departments of UTAT come out. They have experiments to show, and it's really sort of a nice interactive event with the public. Okay. So besides that, there's also other reasons why. We also have people like myself who will annoy anybody that I meet and tell them to join UTAT. And the reasons why people join, as I said before, are quite broad, and the skills are quite broad. So we exist to promote aerospace from an interdisciplinary perspective, beyond just saying it's about designing aircraft. You can learn the kind of skills that you would need to design other types of electrical solutions or other types of software solutions. We have, for example, a very big emphasis on computer vision and machine learning and image processing, which could be in aerospace or could be elsewhere as well. Okay, so in the end we smell quite badly of these things. Although sometimes we actually do smell when it's testing season and you're up at the Institute for Aerospace Studies for more than 24 hours. Okay, and I'll just talk a little about the individual divisions. So the Aero Robotics Division is our quadcopter division. It has between 10 and 20 students. And the idea here is we're designing unmanned aerial systems, or UAS, for a particular competition called the Unmanned Systems Canada Competition. And that's sort of what it looks like. So it's an annual competition. We either fly or drive out to Southport, Manitoba in Canada. And from year to year, the objective of the competition changes. Most recently, the focus was on crop monitoring and agricultural monitoring, as well as deploying a payload to a sort of a target location on the ground. And so for this particular design, we had a quadcopter design that we had come up with. Everything, again, as I said before, was manufactured by students, also programmed by students, and we operate on a one-year design cycle for this. So this past year, we were out there end of April, early May, right after exams, an extremely intense time. And let's see if I can just show you kind of what it looks like. So the idea is that when you're flying in the sky, this is one of the images we took. And this is what it looks like. So it's a bit of a mock scenario, but the idea is that you have an open field, and you're trying to recognize different objects on the ground. You are bounded by these little red markers here that are placed on the ground, and the quadcopter, and whatever sort of ground station, ground computer you have, has to recognize where those markers are, be able to identify what is the sort of the simulated crop area, and then identify objects in the middle. So we have a QR code. So it has to recognize that QR code and be able to process it. It takes you to a link somewhere. If you do that, you get extra points. You also have to calculate the total area enclosed by those red markers inside, and there's also sort of a fake IR signal if it was something like a person in the field or a piece of equipment or machinery. Okay, this is sort of what it looks like, a little bit up close. We typically send a 4 or 5 person team there, and we also have trained pilots. For anyone who's concerned about the regulatory side, we have clearance from Transport Canada to do these flights. We apply for what's called an SFOC, a Special Flight Operations Certificate, which certifies a particular vehicle and a particular pilot to fly at a particular time. So we have that whenever we're flying these sort of experimental vehicles. And on board there, we have 2 main payloads, one of which is a camera that's looking down and handling the computer vision aspect. But one of the other parts I mentioned before was a probe deployment, which for this year was a very non-realistic roll of toilet paper. So normally you have a sort of a nice, full, soft roll of toilet paper kind of sitting underneath there, and there's a target on the ground you're supposed to drop over. If you manage to drop it in, great. If not a big deal. But yeah, that's more or less it. On the far left, we have it's a little bit hard to see, but it's a screenshot of a program called Mission Planner. So this particular quadcopter can fly either in manual or in autopilot form. And Mission Planner is a software that anybody can use, which you can integrate it with a vehicle like this and be able to do simple waypoint navigation. So you say, go here, 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 and it'll just do simple lines in between those waypoints. So yes, we placed second in phase 1, which was design report and 10th overall at this national competition. So next one takes place again next year, this time in Quebec, and this time the focus is on wildlife monitoring, and the challenges are even more intense. So this time we're supposed to be trying to track wildlife movement or migration. So identify a number of geese. I don't know if they're going to be real geese, but we're supposed to identify geese. Identifying nesting pairs, and the really, really hard part is making us retrieve an egg from a nest, which I don't believe has been done before. But that's going to be an interesting challenge. Yep. Besides that, Unmanned Systems Canada is an organization that does far more than just the competition itself. They exist to promote unmanned systems, not just aircraft, but also ground-based across Canada. But the student UAS competition is sort of their pinnacle event for university students to get involved in. Okay, and this is sort of what the system looks like. I won't get too much into the details. I'll keep it conceptual. But you sort of have the flying quad rotor in the sky. We have a telemetry downlink to the ground station computer. On board, we have a Pixhawk autopilot, which is just an off-the-shelf autopilot that you can program to control your aircraft. And then this is also kind of really neat, the Jetson TX1. So this is a module that was recently developed by NVIDIA, a major graphics card electronics company. But the Jetson TX1 is essentially a miniaturized supercomputer that you can put onto your vehicle, and it's intended to do image processing while in flight. So that's something new that we're trying for the coming year. Besides that, for the coming year, we also have, again, some high-resolution cameras there. Mission Planner is essential for any of the autopilot stuff that we're doing, identifying waypoints, and also training pilots. So we always have at least one backup pilot in addition to the main pilot that we're flying with. And training them can be both an interesting and expensive thing, especially when things crash. Okay, so UAV. So the two particular teams could be named a little bit better, and we're probably going to change them in the future. But the main difference between air robotics, which you just saw, and UAV, is that UAV focuses on fixed-wing drones, whereas air robotics focuses on quad-rotor hovering drones. For the first time this past year, we actually had 2 divisions of UTAT that were competing against each other, because both the UAV division and our air robotics division attended the Unmanned Systems Canada competition. And I'm also very pleased to say that we took first and second place. So this is, again, focused on the fixed-wing side. I won't go over this again too much, but it was the exact same competition. We had 2 vehicles there. One was a fixed-wing, one was a quadcopter. In addition to that, one competition that our UAV division participates in exclusively, at least within the team, is AWSI. So this one is a little bit more sort of less application-based, more based on just enabling capabilities for drones. This takes place in the United States each year. For this, again, you're supposed to recognize objects in the ground as before, but you're also supposed to identify, okay, be able to read that that's a letter Y, this is letter R. In the past, they've had camouflage military vehicles on site as well that you have to do image recognition of. And so this past year, we replaced 10 internationally with that. Okay, so now it's time for video. Sorry about that. Okay, let's try to see that. So what you would have seen is just an overview of the different vehicles that we work on, and seen them actually in flight. We have an onboard camera that you would have been able to see what it looks like from the vehicle itself, looking down. We typically fly them at an RC aircraft field up in Luncheon, which is just north of Toronto. And we also fly at the Cochlear Scientific Reserve, which is operated by UTAT. So yeah, some plans for the coming year is to continue building this one platform we've been working on for the past 3 or 4 years. Every year we modify it a little bit more. But one of the other kind of neat ideas that we're doing for the coming year is this guy over here. So one of the challenges that we're supposed to be competing at in future years is something called the UAV Challenge Medical Express, which takes place in Australia. And the challenge there is that we need to be able to take off in a relatively constrained landing or takeoff airstrip. So what we're designing right now, and we've already gotten working from the quadcopter mode, is a UAV which is essentially designed in a very modular way so that it can function either as a quadcopter and take off vertically, but you can also strap wings to it and turn it into a fixed wing. So that's the UAV side. Rocketry division, which is closer to my heart because I simply started in it, specializes in the design of what's called hybrid rocket propulsion, or hybrid rockets specifically. And I'll explain what that is shortly. But the idea behind hybrid rockets is that you have an oxidizer and a fluid, so propellants that are in different states of matter. And in our case, we have a liquid oxidizer and a solid fuel. This is a cross-section of a rocket from this most recent year that we flew in Utah a couple months ago. And the idea behind rocketry is that we're interested in learning about the technology, the propulsion side and the structural side, but also carrying useful payloads in the nose cone to conduct scientific experiments. So this past year, we competed in the advanced category, which was to take a 10-pound payload to roughly 23,000 feet. That's actually not that high compared to some of the other rockets that are currently in existence. 23,000 feet is probably just over 6 or 7 kilometers in the air. But that's just one nice snapshot we got of the rocket taking off from the launch rail. I do have a video for this that does not rely on the internet, so you'll be able to see that in just a second. But before I get to that, I just want to explain a little bit more about hybrid propulsion. So this is what a typical hybrid rocket engine looks like. So you have the engine itself here with the fuel grain. In our case, we're using paraffin wax, so candle wax, just regular candle wax. We have a nozzle. We've got some plumbing in the middle, and then we have an oxidizer tank. And the oxidizer we use is liquid nitrous oxide, so liquid laughing gas. So our entire vehicle is powered based on materials that you can find relatively easily. And the idea here is that when it's time to ignite this engine, a valve or some other mechanism in between the oxidizer tank and the fuel grain will actuate. Oxidizer flows into the engine, you ignite the engine, and then you have the engine burn. And then Newton's third law, you're throwing a bunch of stuff out this way, so the rocket ends up going another way. Key challenges here, we're trying to mix wax with a liquid, which in general is quite hard. On top of that, hybrids in the past have typically suffered from combustion instabilities. So once the engine starts going, we have these really high pressure oscillations and fluctuations that can cause serious damage. And on top of that, it usually suffers from what's called low specific impulse. So specific impulse is, you can imagine as the total change in momentum per mass of propellants that you're using inside the engine. So compared to liquid engines, which are the kinds of engines that you find on the kinds of rockets that would take satellites into space, we're usually about 2/3 of that. But some of the advantages of it are that it's much safer than other kinds of design. If you think about purely solid rocket motors where all the propellants are molded together, if you have a spark inside your engine, that thing's going off and you can't control it. We also have the advantage of being throttleable. So you can imagine if we had some sort of electronic actuation system that could be remotely controlled, you'd be able to fine-tune how much oxidizer is flowing into the engine at any given time. And then it's really simple to operate in the sense that you can get it burning really easily, but again, getting it burning at a high efficiency is quite difficult. So, So for this past year's design, we'll just talk a little bit more about one area that I personally worked on, which is the injector current. So you can imagine if you have this oxidizer spraying into this engine, you get a much higher temperature, higher pressure burn, violent chemical reaction if you were able to disperse that oxidizer much more finely into kind of a really sort of thin, fine mist. So the purpose of the injection system or injector plate is to do exactly that. And so we'll go through a number of hand calculations as well as numerical simulations in a computer, and then try to validate them in practice. But there's a catch. Nitrous oxide also functions as a monopropellant, which means that just the oxidizer alone can also function as a propellant and can be quite dangerous. In 2007, Virgin Galactic, which was kind of an effort that's still going on right now in the States to launch satellites, had a catastrophic explosion doing testing with nitrous oxide, with laughing gas, that actually killed 3 people. We don't want that. So instead of using real nitrous oxide, we actually test with carbon dioxide, which has similar thermodynamic properties to nitrous oxide. And this is what one of the tests typically looks like.
5, 4, 3, 2, 1, open.
Fairly simple. Injection systems right there, and things that we're looking at include what's the pressure drop across this injection system? Are we getting the kinds of flow rates that we want in order to sustain the kind of performance that we need? And some of you may be thinking, oh my gosh, you're dumping carbon dioxide into the atmosphere. Nitrous oxide is about 200 times worse as a greenhouse gas. So this is actually an improvement. So then we do that. So we do the cold flow testing. We get the kind of results that we need to validate just the injection system. We also do testing, isolated testing, and other subsystems for this engine. And then we put everything together and we do a full integrated engine test, which looks like this. So that's done at the Institute for Aerospace Studies, which is close to Tuckerman Steel. The engine, we flip it upside down, we bolt it into the ground. The oxidizer tank is sitting just over here, flows into the engine, injection system's pointing up, and then based on that test, we got these results. So it's about 400 pounds of thrust over just under a second, so very quick. But our rocket weighs about 70 pounds, and by the time that it takes off the launch rail, it's going at about 10 Gs. So we're done with the engine. We put the engine inside the full vehicle. This one might be a little bit harder to see because we took it with a cell phone. But what happens is, after everything's put together, we go to this competition in Utah. We spend 36 hours driving there. And getting across the border with the rocket is not so easy. Especially when some of the members in your team have Chinese passports. But eventually you get there, you set up the launch rail, it's in the middle of the desert, you don't have to worry about hurting anybody really, as long as you yourselves are being safe. And so the rocket is sitting on a rail here, just at the bottom, and that's the rail itself, and I'll just play the video. So, that's one less step. And then eventually, there's a parachute inside, so we end up recovering the rocket. For the coming year, we're planning on rebuilding this particular vehicle. Our engine actually ended up underperforming. People made fun of us because they were like, oh, the Canadians forgot that it was hot in the desert, and some wax sort of got spat out before we intended it to. So for the coming year, we are rebuilding this rocket. We intend to launch it in Canada. And on top of that, we recently partnered with Canadian Forces Base in Gagetown in New Brunswick to try and break the Canadian amateur altitude record, which is 44,000 feet. So for that, we'll be basing a lot of our design based on the most recent launch vehicle that we developed, and then going out to New Brunswick sometime in the summer of 2018 and launching from there. And And what we're hoping is that in doing so, we'd be able to convince either defense or the Canadian Space Agency that there is some expertise in Canada for doing this, and it doesn't really cost that much. And I'll tell you about the cost for this at the very end. I think will be pleasantly surprised. So that's the rocketry division. Now on to space systems. Okay, so in addition to the quadcopters and fixed-wing drones and rockets, we also work on small satellites. So the typical thing that people think of when they think of satellites are these large, kind of multi-ton communication satellites that are sitting way, many thousands of kilometers in space. But the kinds of satellites that we work on are the picosatellite range. So between 1 and 10 kilograms, so very light. But what's neat is that advances in electronics, advances in power systems and solar panels have allowed us to create useful experiments that can actually be integrated onto satellites of this size. So what we do with our Space Systems Division is perform scientifically relevant experiments on human pathogens. So it's on top of being a satellite that is small, we're actually using it for medical research in what's called a 3U CubeSat. So CubeSat is a satellite standard that says we build satellites in 10 by 10 by 10 centimeter blocks. So this is 3U, so it's 10 by 10 by 30. And this is our actual satellite, our first iteration of it anyway. And the reason why we're doing this is because normally to put a payload onto the International Space Station requires an extensive amount of regulatory approval. And it sort of goes, okay, do you have moving parts? If not, better. If you do, makes things worse. Okay. Do you have fluids on board? If not, better. If you do, okay, it's a little more tricky. Do you have living things on board? If not, better. If you do, again, makes things more tricky. And then the worst part is, are the living things dangerous to people? And in our case, the answer is yes. So our hope is that in using an isolated platform that's just contained inside a satellite, we'd be able to do the same kind of research for a similar cost to launch anyway, without having to worry about putting people in danger. And I think what's really neat about the coming experiment is that, let's see if I can find it here. Maybe we'll just go back. Sorry. So what's really neat is that the experiment that we're working on right now is testing on a couple strains of yeast. And these particular strains of yeast grow inside everybody's gut, my gut, your gut, everybody's gut. For average people who are perfectly healthy, they don't cause any issue, they sort of sit there. But in people who have compromised immune systems, they've been known to result in a pretty wide range of symptoms, even leading up to death. So what we're interested in is, how can we test the effectiveness of different drugs or other kinds of medical treatment on suppressing that behavior? And some really cool experiments that NASA did a few years ago showed that by just putting these yeast into microgravity for a significantly long amount of time, it was able to trick them into thinking that they were inside somebody who had a compromised immune system. And what that means is we can now test with these drugs in a satellite, in space, not inside people, but ultimately get insights that could be useful for life on Earth. And so on board inside the satellite, we have what's called a microfluidics chip, so tiny little channels in which these cells are going to be living. They're desiccated at first on Earth, and then once they're in space, we flow some water over them, we come back to life, so to speak, and then we do the different kinds of testing of drugs. And we track variations in gene expression. So the genes are tagged with a fluorescent protein, and particularly the genes that are affiliated with this kind of dangerous pathogenic behavior. Next slide. And like with all the other divisions, we go to a competition each year, the Canadian Satellite Design Challenge, which will be a 10. This is a 2-year cycle because it's a satellite that kind of requires more time. But every 2 years, a number of teams across Canada, not just UT. This past year, I believe there were 12 universities participating in this, something to that effect. And then we have these workshops that are held at regular intervals. And the idea is to simulate the actual or sort of a realistic design process for creating a satellite. That's a picture of the 4 members we sent to David Florida Labs, which is run by the Canadian Space Agency this past summer. So yeah, so for the coming year, we've done sort of the first iteration of the satellite. We did a bunch of testing. We realized that things don't always work out as we had originally planned. So we're going to continue to refine that design. This is, if you take off the solar panels on the outside, this is what the inside looks like. So we have a bunch of electronics at the top. And this large pressure vessel in the middle is what contains the biological experiment. And yeah. Another part too is that launch funding is insanely crazy. To launch a tiny 3-kilogram satellite like this would cost you between 200 to 250,000 US, also very important, which for a student team is it's unthinkable. So what we're working on right now is getting a student levy from the UT Students Union to help fund some of these costs in a 2-year cycle. And then also looking at companies that might be interested in simply sponsoring a launch if they realize that we have to launch something else anyway and there's enough space to fit this satellite on the side. Okay, so that covers the 4 design divisions that we have. Air robotics, which does quadcopters, UAV, which does fixed-wing drones, rocketry, which does satellite rockets, and space systems, which does satellites. Last division is outreach. Oops. And the outreach division is really focused on professional development and educational outreach to the broader community besides just UTAT. What we realized a couple of years ago was that we were working on all these kind of really interesting designs that were helping students learn practical skills in engineering, and we thought we'd try to share that with the broader community. So, some of the things that we've done. Okay, so some of the things that we are doing and that we've done include what's called TSA8, or Toronto Students Advancing Aerospace. This is a collaboration between U of T engineering students, Ryerson engineering students, which is probably the first as well. But the idea here is that we're trying to provide professional development opportunities to university students while they are still studying. And this will be the 3rd time that the conference is held. It's taking place at the end of this month. We're bringing in between 6 and 8 speakers, and also hosting a case competition so that students can really delve into the industry side of aerospace. In addition to that, we also go to externally organized events and conferences. So for example, in the past, we've had students go to CASI, the Canadian Aeronautics and Space Institute. They host an annual conference that alternates between a focus on aviation and space. We've had students going to public events, hosting talks or workshops at the Ontario Science Centre for member students. And then we also go into high schools or even university classes to give guest lectures on things that we're working on. And so that's the TSA logo. Mina Mitri is a former president of the UT Aerospace team, who also helped organize one of the past TSA conferences. Very recently, he started a satellite communications company in Toronto, and they recently raised $5 million, and they're trying to provide real-time access to satellites, specifically smaller satellites. So they're getting some traction as well. That's me at the first outreach thing that I did. That's Helen in the Sanford Plumbing Building. You can recognize the room at all. We've also had some great meetings with people in industry. That's our Director of Outreach with Jeremy Hansen, one of the next astronauts from the Canadian Space Agency. He's currently waiting for a flight to go up to the ISS, probably after 2020. We also host events like the Canadian Undergraduate Tech Conference, another conference focused on university students. And so here we have, again, our Director of Outreach holding a rocket engine and sort of showing that to different people. And another cool part about outreach too is that because it's mostly focused on people and interacting with the outside world, there is really no hierarchy inside this. There's no leads really except for the Director of Outreach. And we really have a focus on people joining the team, not just to do things that we already do, but also bring new ideas in as well. So the idea is that we're sort of like the aerospace kumbaya, and we're just having a great time sharing everybody with you. This is a very recent photo from the Ontario Science Centre, and what we really like about this photo is that it sort of highlights how excited people get about aerospace. This was for one of their, so the Ontario Science Centre hosts what's called star parties at the end of each month, mostly attended by younger students up until high school. What was neat about this is that we had just arrived, and we were carrying our rocket with us. And we didn't even have a chance to set up yet. Our bags are on the table, and kids are already kind of like swarming in and being like, what is this, feeling things, kind of getting a tactile experience, asking questions. And the parents are also interested, and they're sort of in the back, a little bit shy of the kids, sort of being like, that's cool, but I don't want to embarrass myself. Yeah, so this is what outreach is about. one of the really new and interesting things that we're doing is we've partnered with the Canadian Space Agency and the National Research Council of Canada to host Canada's first reduced gravity flight challenge. So next summer, we'll be sending 4 teams of students to go to Ottawa to participate in zero-G flights. So the National Research Council operates a tiny airplane that can fit maybe 3 or 4 people inside that can do microgravity experiments. And I believe it's nicknamed the Vomit Comet, but you do 20 parabolas or something like that. And each parabola lasts maybe 20 or 30 seconds, most. And in that time, you're floating around inside this aircraft because the aircraft is following the same trajectory as an object would in sort of free fall. And you can do some really neat experiments without actually having to go into space. Okay, and the last part, I'll speed through this very quickly. So the stuff that people usually see is all this, right? They see the designs, they see the outreach, they see all the technical skills the students are learning, but there's obviously a lot of background work as well, as I've realized. So the Administration and Advancement Office usually comprises people who have been in the team for 1 or 2 years. They really care about what they're doing, and they're motivated to sort of perpetuate the same experience that they had, but for other students while taking more of the back end role. So the idea here is that Administration and Advancement, or A&A, is responsible for strategic planning, supporting the technical activities of the individual divisions, and in developing strong relationships with the industry. So on the top right, there's a brief screenshot of our website. And bottom right, this is also really neat. We recently signed a memorandum of understanding with the United Nations to collaborate in providing opportunities for students in the space industry. So that was signed at one of the major aerospace conferences. As I said before, we did have Jeremy Hansen come by. He's now the proud owner of one of our official kind of team polos. We also host an annual Aerospace Showcase event. So at the end of this presentation, there will be a small link. You're welcome to take photos or to ask Lori for my contact information. But in March of every year, we do host a public unveiling event where we show to the world all the things we've been working on for the past year. This past May, we had about 200 or 300 people come out to that, a third of whom were from industry. This is just one of the photos from that. So we have tables for our sponsors and partners to set up there. We also have our designs on display. We had some people from the Space Channel, from Metro News and Toronto Star. Really, really fun event, and also very exciting for students. This photo, I think, is kind of neat. So this was 2 years ago at a conference that was held in Toronto. And I think this sort of highlights what UTAT has become since being that team of 5 students in 2004. So this is one of the discussion panels that was held at this conference. I was lucky enough to be there. They asked me to be there. But here's the cool part. So there's UTAT. On my right is the head of the German Space Agency. And this particular panel was focused on providing opportunities for young professionals and minorities to get involved in space. So UTAT was there, head of the German Space Agency was there. On the other side, we have the CEO of HE Space. HE Space is one of Europe's major aerospace and defense contractors. And then on my far left, we have the Chief Admissions Officer to the International Space University, frequently nicknamed the Space Mafia, because they are connected to all the different sort of heads of agencies and corporations around the world. And this is just a photo from a past conference I was just at in Mexico. All the Canadians got together and took this nice photo with the Canadian flag. So yeah, we have a number of people that support us, and then some major collaborations we have for the coming year. We're working with the Canadian Space Agency to help define the coming space policy framework. We just had a federal election, and the dynamic within the government has changed, where instead of telling the Canadian Space Agency, this is what you need to do, they're actually asking them, what should we do? And so now they're also consulting with groups outside the CSA. We're working with the German Space Agency's Institute for Aerospace Medicine on our medical research satellite project. We're working with the Department of National Defense on some concept development projects, as well as with launching our Standing Rocket in a couple of years from now, working with the UN, and then also working with the University of New South Wales in Australia on doing an in-space satellite relay for data, trying to establish in-space communications line. And I'll skip over that. So yeah, overall, really exciting. I would say that, as someone who spent their first semester with the team, working for 6 months on something and not being able to see something, until the very end, this was my very first engine test that I got to witness. And for those brief, 10 seconds that this engine is going off, it's like nothing else in the world matters. Everything is shaking. You can't hear anything. Environment Canada is nearby, which is not great. But it was a lot of fun. And to know that that engine would actually be integrated on a real flight vehicle and be flown and do something of use to science was exciting. We also got some pretty nice photos. We now have official team headshots and official flight suits that we give to our team members. There's obviously some media coverage. And then, of course, it's also nice to just have a community of people that you can kick back with and relax with. And then, on top of that, whenever we do go to competitions, we try to make the best of it. So last time we went down to Utah, we actually made a stop at Grand Canyon. So these are the team members that have went and had some pretty nice experiences there. There's obviously a lot of bad as well. Things don't always work out. Things break. Theory only brings you so far. We have to do a lot of testing. There's also a lot of sort of grunt work involved that people don't really think about. Everybody gets really excited by the engine tests and the actual flight, but nobody gets excited about cleaning plumbing. So this is us cleaning plumbing for our rocket engine test. And it's just as important because if you miss a speck of dirt, that could end up igniting when you don't want it to. And of course, it's a huge logistics problem. This is all the stuff that we had stuffed into what was essentially a walk-in closet. Space downtown is at a premium when it comes to student design teams or even research labs or whatever it is. So managing that is also a huge challenge. And then there are things that we just usually don't tell the outside world about. It's really tiring doing this kind of work. I actually love it a lot. And that's also one of our team members sleeping with a rocket, not while we're still with it. As I said before, we had a couple of startups. So Kepler Communications is the satellite startup that was founded by some UT members a while ago. And so this is sort of contributing to this identity crisis that we're having, where we don't really know if we're a design team or if we're sort of like an incubator for people who want to do aerospace startups later on. I'm not sure if this is going to work. Okay, anyway. Besides that, the startup we're currently at is hosting another huge conference December 6th and 7th. It's an industry-focused community conference. We're bringing in about 3,000 people worldwide. And this is going to be focused on getting industry to adopt drones in Canada. So we're bringing in people from across oil and gas industry, mining, manufacturing, real estate, really quite broad. And in addition to that, we have some great speakers lined up. The Director of Education for DJI, the world's largest manufacturer for consumer drones, is going to be speaking. We have some speakers from Lockheed Martin, Canadian Armed Forces, Department of National Defense, law enforcement in the Ontario area, RCMP, CSIS. Rogers is going to be there, thinking about how do we provide the data solutions necessary so that drones can work, and many others. And so tickets are currently live. It'll be taking place downtown Toronto at the Enercare Centre. And if you're not doing anything December 6th and 7th and want to learn something about drones and what Canada's doing, we strongly recommend that you come out. And so, in the end, by all means, please let me know. What we're increasingly realizing is that students are really excited about aerospace, even if they themselves don't see themselves in aerospace later on. And so the idea is to just keep on growing and growing and growing and growing. And the mindset underneath everything we do is that people aren't afraid of hard work. They're afraid of the work that doesn't matter to them. At the same time, they want to do those things that you can be passionate about and that you're willing to spend 12 hours a day when you have a midterm the next day to work on. And at the same time, provide those to know what it is that actually matters to you. It's very easy to go through university just completing courses and doing what other people tell you, but eventually society kicks you into a corner whether you like it or not. So being able to have that ownership over your own career, to choose that adventure and then to create new adventures altogether with other people. So with that, we have a number of ways that alumni can also get involved if you're interested. We have a number of people working with us that are functioning in a technical advisory role. helping us with design critiques when we do host the occasional design review, or providing other kinds of multidisciplinary support. We also have strategic advisors who are telling us about new things that are happening in industry and recommending things that we should get involved in. And then obviously there's a sponsorship component. And yeah, that's basically it. So thank you very much for having me. I hope that was somewhat enlightening and gave me just a taste of the kinds of stuff that students and youth here are now working on. Just so glad that I found this team and didn't end up doing something I would not have actually enjoyed. So thank you very much.
At this point, we'll open the floor to questions. We have plenty of time. Yes, I think it's Bob Ross, way back in the back.
To what extent are you supported by the faculty of the university? To what extent do they give you academic credit for what you do?
Yeah.
Do they control what you do at all?
Right.
How do you...
What's the relationship with? Okay, so it's what I do like is that the approach is very much hands-off in the sense that we'll apply for funding from school alumni or departments or other funding sources from the faculty. In total, that probably comprises about half of all monetary funding that we receive, and the other half we get from industry. In terms of what the faculty requires from us, they don't really say much besides saying, if we like what you're doing, we'll support you, and you just go and do it. So we have a lot of freedom in terms of being able to be ambitious and being able to grow. We're not limited by what the faculty says. At the same time, there are certain aspects of funding that we'll try to go for that are targeted towards particular areas. So, if we're going for funding after mechanical and industrial engineering, we better have projects that are relevant to what they're doing. And then at the same time, we're also partnering with faculty on doing research. So for the rocket that we're planning on launching a couple of years from now, that's going to break the altitude record, we're partnering with professors and researchers under the mechanical and engineering department to launch a microgravity science field.
Questions? Yes.
Now, would you be familiar with what's happening in North Korea? They're developing the long-range rockets.
Yes. So North Korea recently launched their first satellite, I believe. Although once it was in orbit, it became unstable. As a Canadian who's really excited about aerospace and knows that we don't have a launch program, it was a little bit sad to see. And in my mind, I was thinking, if North Korea can do this, surely Canada can do this as well. But from a sort of global relations point of view, at least from our perspective, we're not too involved with the policy side yet. So far, we haven't done anything particularly destructive yet, so I'm not that concerned.
Normally we've got aisles of questions. Oh, Jim Carter.
So while I was talking with Jeremy came back from this conference with Mexico, and the keynote speaker was a person named Elon Musk. How many people know who Elon Musk is?
Yep.
Okay. He is the founder of Tesla, the electric car that just sold, what was it, 300,000?
Yeah, some crazy
Model
number.
3s. So they've got about 3 years of backlog of production to do. He's the founder of SpaceX, which you saw referenced here, which is working on the reusable launch vehicles. So they're the ones that are sending rockets up and trying to get them back to land, either on ocean platforms or now back at, say, Cape Canaveral and so on, and being reusable. He's also got Solar City, which is biggest project is they just signed a major contract with a utility in Los Angeles to use solar panels to provide electricity for 2,500 homes. And it's sort of a backup to other modes of generation. But then at this conference, why don't you mention basically what he introduced, because this is a mind-blowing concept on how to get to Mars.
Yeah. So Elon Musk was at this conference we had just held, and the room was absolutely packed. He was unveiling his plans for going to Mars by it's 2030, sometime within the next little while. Very soon, yes. And so the plan was to develop this launch vehicle that could overcome some of the key challenges in rocket propulsion and in orbit assembly to take people, large numbers of people, to Mars instead of a colony here. And it's just from a technical point of view. I don't have the pictures with me, but the size of the vehicle that they're developing is 20 or 30 stories tall. They're planning on taking 100 people at a time, and they're doing it largely on their own with some funding from NASA, plus whatever they already have.
Well, apparently they just signed a major, or at least Obama has just signed some stuff to help encourage that law.
Yeah. And it's an interesting project for a number of reasons. And there's also a lot of skepticism about why do we need to spend all this money on going to Mars? Is it really going to be that useful? But at the same time, it's also interesting from as I mentioned before, from a societal point of view. This is almost like a chance to start fresh politically and societally, particularly with the federal elections just around the corner. How do you set up a society based on all the lessons we've learned and see if that works out, particularly when people are being challenged and trying to survive in a harsh environment. So it's very neat from a curiosity point of view, but there's also a lot of controversy when the funding is well spent.
There's actually a YouTube video of this thing, and I'll put the link out for people to be able to go and watch that video. It's about a half-hour show, but it's very interesting to see all the engineering development that's gone into it so far. All, go back through and see, God, there's my first year of physics, all blowing up and being used and so on. And the whole concept is to get a vehicle up in orbit around the Earth and then take these reusable launch vehicles and take fuel cells up to it, and then they send the vehicle out to Mars. They're looking at 2 to 3 year cycles to go up and come back. But it's pretty mind-blowing.
It is. And at the same time, NASA is also trying to develop their own kind of space launch system for going to Mars. So there's a possibility of big competition.
The question is, who gets there first, private industry or
The government.
The government, yeah.
Any other questions? Yes, Miriam.
Just a simple one. You mentioned going across the border and having some difficulty because it's with Chinese passports.
Yes.
Just related to that, in terms of the 85 plus students involved in this amazing adventure you have, how many are sort of Canadian citizens? What's your sort of proportion there?
We don't, so we have yet to start tracking it formally. We should though, because we do like to know sort of what our demographic makeup is. But if I had to estimate, it's probably between 20 and 30%.
Did you say 20 or 25% are Canadian?
No, are foreign.
And I think that's consistent with the demographics of the student population at U of T. I think 20 to 25% of all students at U of T are international students. So the Aerospace Club is representative of the rest of the student population from the sounds of it. Questions?
I do want to mention as well, in terms of just the cost of doing this stuff, in case if anyone's interested, the drones we develop are between $5,000 and $10,000 to make. That's mostly material cost because we fabricate and assemble everything ourselves. The most expensive thing by far is our satellite, which costs about $30,000. And although those numbers are a lot for the aerospace industry, it's not that bad. And we also have a lot of support in terms of in-kind sponsorship, companies donating materials, and the rest of these. Just in case you're wondering. And the rocket is about 10 feet.
Or feel so inclined. I mean, this was the soft sell that Jeremy didn't want to talk about. Yes, sorry.
I'm just going to say thank you for a very interesting presentation. It was not going to help me fix the toilet.
Is there a plumber in the house?
Well, you know, we've gotten pretty good at plumbing because of our rocket. So, you can call us.
Now, is there nitrous oxide or wax in your toilet? If there is, these guys can fix it.
Well, if there is, you'd be laughing a lot in the toilet.
You're right.
Yes.
If there are no more questions, let me take just a few minutes. If you'll step aside, please, Jeremy. On behalf of the Lunch and Learn, it's my pleasure to thank you on behalf, and this is our first luncheon. And given what I said, the difficulty we had getting the meeting notice, we're pleasantly surprised. It turns out we ended up, I think we're anticipating 39, we ended up with 43 people here. So thank you all for showing up today on such a beautiful fall day. Jeremy began by sharing with us the vision and the mission of the aeronautics team. I mean, now what is the aeronautics team? It turns out there are many disciplines, there are many interdisciplinary students involved in this team. That he shared with us the activities and the plans for the aerial robotics, the unmanned aerial vehicles, which we've heard a lot about, drones and so on, the rocketry division that he has been personally involved with, and the space systems division, and the plans that each of these divisions has in mind for the coming, because the year is just beginning. He talked lastly about the outreach division and how they are trying to reach out to other student groups. So I don't know whether young Daniel over here is a prospective member for you to reach out to. And I would encourage, and I realize you sat next to one another at lunch, but perhaps you want to sign up young Daniel. It was obvious from Jeremy's presentation that he's very enthusiastic about the activities of the Aeronautics Club, and he's only one of 85 members of that multidisciplinary team. So again, please join with me in thanking Jeremy. Lastly, let me just close by first off telling you that the program for the coming year is fixed right to the very last. We have got speakers lined up for the second Wednesday of every month from October through to May. So clear your social calendar, plug in the second Wednesday of every month from now until May. I won't go through them all, but in November, which is next Wednesday, November 9th, we're going to have Professor Ron Venter, who's a professor emeritus, and he's going to share with us details of the new Center for Engineering, Innovation, and Entrepreneurship. And that is the last building that is being built on the U of T downtown campus. It is next to the other engineering buildings as one. And he's going to talk about leadership in engineering education and collaborative activities, and that is what is going to be going on in this new building. On December 9th, which is the second Wednesday in December, we have Mark Zwelling, who is the president of Vector Poll. He has written, Tom Vosper brought him to our attention. He is author of several books. One is Polling for Dummies. Now, he's not going to talk about polling for dummies. He's going to talk about entrepreneurship for dummies. So for you dummies in the room that have an entrepreneurial interest, perhaps you want to join us on that date as well. Come anyways, even if you're not interested. In January, we're going to have a presentation on meta materials and meta surfaces for microwaves to optics. We're going to have presentations on tracing the fate of environmental contaminants and achieving their removal, how that's going to be done. We're going to have a presentation on research on clean energy. And lastly, thanks to Jim Corcoran, who is involved with the Pan Am Games. He's also involved with the Invictus Games, which are are being held next year. And we're going to have Michael Burns, who's the CEO of the Invictus Games, who's going to be talking the master of my fate, the captain of my soul, and I skipped in between. March is our annual awards luncheon as well. So again, we have a full program. Everything is finalized. A couple of the speakers' topics have not been finalized yet, but I would encourage you to plan to attend November, December, and as many, for those of you that are snowbirds, when you get back in the spring, please join us at that time as well. So at this point, thank you for coming. Jeremy will be around if you want to chat informally with him, and we look forward to seeing you on Wednesday, November 9th, for Professor Ron Richard. Thank you.